All right, example 3. I need to solve this inequality and write it in boundary notation. I know this is a rational function. The reason I know it's a rational function is because there is x's in the denominator and it's a fraction. Okay. The way we the way we solve rational functions is first by finding our points of discontinuity. Okay. So the first thing I would look for is, are there any holes? Nothing here simplifies, so I don't have any holes, but I do have some vertical asymptotes. So I am discontinuous when x minus 2 equals 0 and x plus 6 equals 0. So at x equals 2 and x equals negative 6. Okay, and whenever you find your points of discontinuity, regardless of this inequality sign, it is always an open circle or it is not included. Okay, so always open circle or dot, whatever you use. Okay, so it's always an open circle on your number line because we're going to have to do the number line check. So those are my points of discontinuity. Then what we do is we also find our zeros of this function. Okay, so if I were to solve this equation, what I would do is multiply both sides by the denominator. That's where my discontinuities go away. And you guys don't have to do this every time. I'm just going to show you here. This would all cancel, and then 0 times all of this just becomes 0. So you are left with x and x plus 4 is greater than 0. So this part kind of comes back to our polynomials. Okay, you just have to include with the rational the discontinuities. So from here, I would set each one equal to 0, just like on our polynomials, and solve. So I get 0 and negative 4. Your zeros always follow what this inequality sign says. So it is not equal to, so it's going to be an open circle. If it was closed, I would if it was equal to, then it would be a closed circle. But the zeros always follow this. Discontinuities, you can never be equal to them, so they are always open. Then what I need to do is go ahead and put all of those numbers, my discontinuities, and my zeros on a number line. So negative 6, negative 4, 0, 2. And putting them in order is the hardest part. I promise you when I grade, that's the biggest mistake I see. And in this case, they're all going to be open. And now we go ahead and test points like we did with our polynomials. So the only new part is really taking into account your discontinuities. And so what do I got? Number less than negative 6. Let's do x equals negative 7. I plug it into the original factored one, factored equation. And so when I do that, I plug in negative 7. So for x, I would have a negative. Negative 7 plus 4. That's a negative 3, so negative. Negative 7 minus 2 is a negative 9, so negative. And negative 7 plus 6, negative. Negative times negative is positive on the top, and then the bottom will be positive, so this is a positive number. Are positives greater than 0? Yes, it is, so I would shade. Then I move on to the next one. I try x equals negative 5. That would make this a negative. Negative 5 plus 4 is negative. Negative 5 minus 2 is negative, and then negative 5 plus 6 is positive. So the top, well, negative times negative is a positive. The bottom is a negative. A positive divided by a negative is negative. Are negatives greater than 0? No, they are not. This is false. So I do not shade there. Then in between negative 4 and 0, I would have, I'm going to try negative 1. I would have a negative. Negative 1 plus 4 is positive, so got that. Over negative 1 minus 2 is a negative, and then negative 1 plus 6 is a positive. So top's negative, the bottom is negative. If I have a negative divided by a negative, I get a positive. Are positives greater than 0? Yes, they are. That is true, so shade. Why don't you take a second and pause and see if you can figure out between 0 and 2 if it's positive or negative, and then true or false, and then from 2 onward. So when you did your try, you should have got that this was false and this part was true. And so then my final solution in interval notation, we're going all the way to the left. So negative infinity to negative 6, parenthesis, union, negative 4, comma 0. And then I still got to pick up again, so it's possible to use more than one u. Then I would have 2 to infinity. And there is your rational function solution. Your homework is the Inequalities Review Worksheet. If you have questions, let me know. Otherwise, have a good day.